Hi, everyone. Today I'll be talking to you about how we can measure building performance through human experience. Specifically, I'll be focusing on what we've come to call a data-driven framework for human-centric measurement of building performance. So, this is very much about the performance of the building in operation. And as you can see from my picture, of course, the context of the last year or so of the pandemic is going to influence very much what I'm going to talk to you about, because of course, COVID has completely changed the way we think about the building experience. This is usually the first thing that comes to mind for most people when we talk about measuring stuff in building. This is usually the reaction that my clients have, a lot of colleagues have, because we're not used to measuring buildings after they're actually constructed. We always think we should, but it doesn't seem to pan out necessarily in practice, right? Well, I hope through this presentation, I can begin to show you that doesn't have to be the case. So here are the three things that I hope you can take away from this presentation. Right? If you remember nothing else about this presentation, here are the three things that you should try and remember. The first thing is continuous monitoring and feedback. So continuous collection of data about human experience, about indoor environment quality is a natural progression of green building best practice. So, if you come to this conference, you're probably thinking about green buildings. If you're not thinking about them, you're at least, if you're thinking about them, you're also probably acting on them. So you are probably a thought leader. You are here to learn. I'm here, I'd like to say that this is actually a natural progression to go from design intent to operational reality. The data gathered are useful beyond just compliance and certification. Obviously, we want compliance, we want certification, but this data is actually more useful than just that. For example, for COVID and re-entry, energy efficiency, controls, and I'll talk a little bit about these applications later. And then, of course, continuous monitoring and feedback does not have to be complicated, cumbersome, or expensive. And that's a real myth that has to be busted. This is probably because, of course, when a technology is new, it can be a little cumbersome, it can be expensive. And, people, I understand the hesitancy around sensors, around collecting feedback. Do you want to expose the building performance? Do you really want to know what people are thinking? But this is all sort of growing pains. And as we move green buildings into the new era of healthy buildings, of buildings that promote health, so data collection, let us begin to be an overview of what human-centric measurement would be. So measuring building performance through human experience, what would this really entail? So before I address that, I really should talk about the fact that, okay, we're talking about health and well-being. That's one of the themes of this conference. And in this particular presentation, I will focus on an aspect of health and well-being because health and well-being is a fairly nebulous concept. I'm going to focus on environmental quality, well, more specifically air quality here. So we're not talking about like acoustic ambience or lighting, which are all important parts of environmental quality and influence your health and well-being. Health and well-being is also influenced by your sort of HR factors, human resource factors, the environment of the workplace, and so on. So in the context of sort of building science, I'll focus on the indoor environment, especially how you measure it and how it affects health and well-being of humans. We know it has a significant impact on human health. There's some just a couple of resources I put down there. There are dozens and dozens of papers and books you can find on the impact of indoor environment on human health, especially air. There have been several existing studies that have linked human health to specific pollutants and the environmental and human health and productivity impact of pollution. So it's not really up for debate anymore. We spend up to 90% of our time indoors. So obviously the quality of the indoor environment has to affect, how our long-term health pans out. And of course, the big elephant in the room is COVID-19. We know for sure that airborne transmission is certain. In fact, I should probably remove the word almost there. It is certain. There is plenty of evidence. We have, in fact, I just noticed I didn't have one of my key sources there. I can add it later. It's beyond doubt that airborne transmission of COVID is happening. If anything, it might be the dominant route. And I know there has been some controversy with the WHO and the CDC and so on, these big organizations and the EU, not really focusing on airborne transmission at the beginning of the pandemic. We were very focused on disinfection of surfaces and all that stuff. And then, more and more evidence has built up that aerosol transmission or airborne transmission is the dominant mode, which means, of course, that ventilation is key, right? And again, I'll bring this back to why the data collection part is so important when you talk about these things. And also don't forget that indoor air is often more polluted than outdoor air. So, that's something that a lot of us don't really think about. But if you really look around at all the pollutant sources in your house, from the kitchen range, from the cooking range to carpets, you look in your offices, you have printers and so on and so forth. You can begin to see why indoor air can be more polluted than outdoor air. And of course, keeping in mind that none of this data management and the data collection and feedback will make the risk exactly zero. That's not what we can achieve here, and that's not what I'm going to claim. But it's something that does affect the risk probability quite significantly. To have a better managed building will reduce your chances of transmitting COVID-19 through the airborne route. Let's say you bought into the science and you think that's a good idea. You think that that's how we should go. So you've designed your building correctly. You put in all the measures in place. You've got good ventilation. You've got disinfection protocols. You've got sort of administrative protocols to make sure that people don't show up when they're ill. You've used the best materials so that they're not, they don't give off VOCs, so volatile organic compounds. You've used great filtration in your HVAC system, and so on, right? But the problem is that design intent does not equal operational reality, right? And there's this big concept in the UK now and across the world of soft landings. A soft landing being when the sort of design and construction team hands over to the operation team and the owners, you don't just sort of crash land. The handover is not just, here you go, here are the keys, bye. It's more along the lines of, well, we sort of commission the building, we show you how to work it. I know there's dozens of steps, and you can look them up on the website. Just sort of Google soft landing, and I highly encourage you to do that. But the point is that design intent does not translate to operational reality in the short term, but certainly not in the medium and long term of the building. Building characteristics change over time. The usage can change, the materials degrade over time, how the building surroundings may change. And, none of this is necessarily bad. That's just how buildings are. So what ends up happening is if you're not measuring the human experience in buildings, you essentially end up sort of with no direction, because you have no visibility, you have no direction. It's the equivalent of flying without radar, or, using I've never flown up an airplane, so I'll use a metaphor that's perhaps something I do understand. It's like trying to ski in the mountains in the complete fog. You don't even know which way is up. And when we think about buildings which are increasingly managed remotely, so yes, some buildings have the facility manager on site. I'm thinking about office buildings or big institutional buildings. A lot of buildings are now managed remotely. Well, how do you know what's going on in the building? Do you just wait for people to complain? Because by the time people complain, they're probably, they're either annoyed, or they've lost productivity, or their health has been affected. So why are we waiting until that's actually happened? Thinking about how to sort of go step by step from where you are as a green building professional, in my minimum category, I've already put stuff that is sort of what you'd expect a high performance building to be today. You need to address complaints. There are step changes in operations. So somebody complains about something and you change it, temperature, ventilation, or whatever it is. So that means it is once and done. You make the change, and then that's it. You come back for the next problem, and then you solve that problem. And there's usually no measurement. There might be some spot checks if you were interested in that sort of thing. If you had a sort of more forward-thinking team, you might have done a little bit of measurement. So let's say you moved on to best practice, right? So then you have some proactive control. You can anticipate a little bit what the usage of the building is going to be, what the climate is going to be, and then you sort of change according to that. You do some post-occupancy evaluation, which usually takes the form of surveys or sort of just interviews with occupants. Maybe the facility manager or the design team comes back and actually sort of visits the building again and talks to the occupants. And you might do spot checks and short measurement campaigns. So, going sort of from a no measurement or very, very little measurement paradigm to saying, okay, well, we do some sort of regular spot checks, or every once in a while, if there's a complaint of something specific, we investigate it with data. Well, what I'm talking about is sort of the next level, the evolutionary sort of trajectory that we should be taking. And that's human-centric continuous measurement. Right. And I know this word human-centric is something that sort of sometimes doesn't, it's also a little bit nebulous. What I mean by this is measuring parameters about a building that matter to the human experience, whether this is air quality, it's acoustic quality, lighting levels, it could be accessibility, it could be perception of the indoor environment, and so many other things, right? I'm just going to focus a little bit more on air quality today, but there are other aspects here. Because that's my specialty. So I should talk about what I know, right? And of course, the natural progression of continuous measurement is real-time data-driven controls. Again, this doesn't have to be particularly complicated. I know this sounds like, oh my, I'm adding so many buzzwords here, real-time, data-driven. But all that means is you have a control mechanism that responds to data that is relevant to the human experience, whether that's high resolution air quality measurements or occupant feedback or anything of that sort, right? And of course, that leads to this idea of continuous commissioning. Continuous commissioning is by no means a new idea. It's existed for decades. I mean, I heard about this when I was in university, and that was some time ago. So, it's just, we're trying to enable continuous commissioning using automation, using measurements, using, including stakeholders such as the people who occupy the building, so that it's truly continuous. It's not just, you come in once in 5 years and you check, some human being goes around and checks everything and makes sure, sort of, ticks boxes to make sure that the system is working as intended. We check every day, we check every hour that the system is working as intended. It's delivering the human outcomes that should be delivered. This framework that I'm talking about, I'll sort of just break it down into 4 simple steps, right? Obviously, nothing's ever going to be completely as simple as I'd like to make it out on the slide, but let's try and at least break it down into 4 categories. So, at the top lies, of course, engineering and administrative policy. You need policy, you need buy-in from all stakeholders. You need to build on existing knowledge to propose sort of, engineering and administrative policy. The second step is you must include measurement and verification, because one of the things I said why it is necessary to measure human experience in this context is because without measurement and verification, you don't know if your policy worked or not. The third part is, of course, informing and engaging occupants, the people who occupy the building, and review and improve, sort of cycle back again, right? So let's get a little bit into the nitty-gritty of what I'm talking about, what kind of measurements I'm talking about. So what are we actually measuring, right? So in this case, I'm talking about air quality. Like I said, there are other aspects of environmental quality and human experience that I won't necessarily touch on today, but they do exist. So in the case of air quality, for example, health outcomes and pathogens are actually difficult, maybe impossible to measure directly. So what we end up doing is we measure indicators, right, such as CO2, or measure known pollutants such as particulate matter or TVOC, so total volatile organic compounds. I'm sure these are words and keywords that you've been hearing a lot about recently, if not before that. And we test periodically for hazards. So your sort of really nasty chemicals, and often that ends up being statutory compliance. So your compliance with laws. And as far as the human experience that we can measure, we can we do need to track outcomes not measurable by sensors. I'm not saying sensors are the be all and end all of everything. They're just proxies for the human experience. We need proactive feedback. So are the policies actually working? Are there hazards developing, or are they being controlled? And nobody knows this better than somebody who's actually in the building, right? And of course, we need user acceptance. We need to increase accessibility, and that's a big part of human experience measurement, right? And of course, there's some caveats here. There are unproven technologies being sold right now. I won't go into the details of what they are, but there are, just because there's a novel measurement doesn't mean it's useful, doesn't mean it's valid. You need to look out for the validation. I'm a seller of measurement tools and systems, and I will say to you, don't believe me. Make sure you have independent academic verification, institutional verification of the claims that manufacturers are making. Ask for data sheets, ask for validation studies. Yeah, I mean, I get it. Don't get too hung up on accuracy and, does it go to the second decimal point? Yes, let's put this into context. Let's have some perspective. But the utility of each measurement should be proven before you start doing it, because sometimes if you measure the wrong thing, you might end up optimizing the wrong thing, and sort of make things worse. Too much focus on measurement can detract from human experience. So yes, I'm talking about measurement and data relevant to human experience. So how to measure building performance for human experience. And sometimes I've noticed, and I'm guilty of this as much as anybody, it's so exciting to measure things using sensors that we sort of forget about the fact that actually at the end of the day, it's a human experience that I can't really quite measure. I can only do proxies. And of course, it must be followed by action. If you just keep measuring, it sort of can lead to disillusionment, where it's like, okay, well, we highlighted problems and nothing seems to have been done about it. Of course, the second big question being when to measure. So of course, as you can see from my subtitle there, my bias is you should measure all the time and everywhere. So I'll talk a little bit about the difference between continuous and one-off measurements. Again, I'm talking in the context of air quality, but this applies to sort of really any measurement. It could even apply to surveys, so continuous surveying versus one-off surveying. And just to make the distinction, we're talking about continuous surveying is sort of leave in place, low cost, and one-off is handheld or short deployments, or potentially higher spec sensors. So potentially more expensive, but also more accurate sensors. In comparison in terms of various aspects of one-off versus continuous measurement, when you do a one-off measurement, you're targeting the measurement. So that can be actually quite efficient, because you'll probably need less hardware, you need less time, and because you know exactly where the problem is, you go there, you measure, you ask people, you survey people, and you sort of try and characterize the problem. And it means continuous monitoring could be potentially less efficient, because you require more hardware, you need to leave it in place, and you have a lot more data. Let's not underestimate handling data and how complicated that can sometimes be. You do address a visible action when you're talking about one-off measurements. So a problem occurs, right? When I say visible, I mean perceptible, right? A problem occurs and somebody talks about it, somebody complains about it, and then you go and reassure the occupants by putting in measurements. You go and ask them, you do surveys, and it's very much in the foreground. And then on the other hand, a continuous monitoring system could sort of be invisible in the background, right? And it could potentially be unloved, ignored, right in the background. Nobody understands why those bits of kit are in the office, and you sort of just leave them there. Which can have sometimes, the effect of just hardware that stays in the building and nobody knows why it's there, and people lose interest in it. So that is definitely a potential downside of continuous monitoring. On one-off measurement, equipment is more expensive, but it's potentially reusable. So you can just have multiple episodes, and you can use the same sensors several times. But be careful, because it's often quite difficult to manage scientific grade sensors. When you leave the equipment in place for continuous monitoring, on the other hand, you will have lower unit costs. So the sensors are going to be cheaper. In fact, sensors are getting cheaper all the time. But that does not mean it has to be lower quality. So this is really a line I must sort of draw under. It's like, low cost does not mean low quality anymore. Right? It's good enough quality that you're looking for. Of course, the trade-off there is that you end up measuring only short episodes with one-off sensing, right? You may not be there when it happened. You may not be able to reproduce the episode. It may not recur of its own. Whereas with long-term continuous monitoring, you can check trends, seasonal trends, long-term performance, which people completely forget. I mean, the building is going to be around for decades and decades. We need to have some idea of long-term performance and degradation and changes. Yes, you target perceptible problems, but only if they are reported. So invisible issues are ignored. You know, sometimes air quality issues and environmental quality issues are invisible. Whereas with continuous monitoring, the occupants don't necessarily need to report. You can just build up a profile over time. And you know, with one-off monitoring, you're being reactive. So you have a problem, you investigate, and then you have this problem, how to reconstruct the problem. Whereas in proactive management, you could, with proactive sort of continuous monitoring, you could have performance-based maintenance. You could catch the problem before it actually peaks, which is, you know, with the very useful things to have. And you know, that was sort of my big spiel on when to measure, so the temporal aspect of it. And you know, I'll talk a little bit about where to measure, right? So you know, one of the things I said was continuous monitoring and feedback do not have to be complicated, cumbersome, and expensive. So I'll talk a little bit about spatial coverage and temporal coverage of sensing, of occupant feedback, whatever it is, right? How often and where do you get your feedback from? So let's talk a little bit about sort of rules of thumb for spatial coverage, normal coverage, and you know, how to improve it incrementally. So I'll use the example of this building. I can't show you the whole building because it's a client's building, but trust me, this is a real building somewhere in Europe, and it's about 1750 square meters. And I put 3 sensors there, and I got roughly 86% coverage if you assume 500 square meters coverage per sensor. So 500 square meters of coverage per sensor is just a nominal coverage. We've sort of drawn those big blue circles around where we think roughly where the sensors actually are in the building right now. And you know, as you can see, this coverage is extending beyond walls. So, well, is that really a good idea? Does nominal coverage actually make sense, or should you really only consider when a sensor is placed inside 4 walls, it really only covers that room, right? So if you were to do that, you'll end up with this, which is about 26% coverage with 3 sensors, because those sensors are inside rooms, and you know, the coverage is reduced drastically. So my point in showing this and the next slide is to show that you know, nominal coverage is a good place to start, but it's definitely not something we want to end up with for the rest of the decade or whatever it is. It's something that it needs to evolve a little bit as our tools to deploy get more sophisticated. And I'll explain in a little bit why I've used those different colors to denote 86% being green and then 26% being red. So if I was to, next slide, if I was to look at 18 sensors in that space with nominal coverage, as you can see here, I do get a fair bit of overlap because obviously it's never going to be perfect. It's never going to be a perfect grid. I spent far too much time in my career trying to make this perfect grid of sensors, and it does not exist. You end up with sort of Pareto optimal location of sensors. So in this case, we looked at 18 sensors, and that gets you to about 75% coverage using 500 square meters per sensor, right? 18 sensors sounds like a lot. I don't think it is, because there is a diversity of spaces, there's a diversity of usages. This space is well occupied. There's fair amount of people there. So you do need to cover their changes in experience and locations as you go around the building. So as I said, it's difficult to define an ideal coverage. And you know, you end up sort of leaning on certification bodies, on standards. So there seems to be this consensus developing around this nominal idea of nominal coverage of a sensor being 500 square meters. 500 square meters is a slightly arbitrary number. I think it's on the higher side of what a sensor can be set to cover. It depends a lot, of course, on the air distribution in a space, on the usage of a space, how many people are in a space, and so on. But it's a place to start. It helps us standardize things, right? And then there are the certification bodies will specify either a minimum or some kind of red, amber, green grades. It is possible to build up over time. You can focus on occupied areas and build up over time. You can increase the diversity of areas measured. So it's not all or nothing in the first day. So moving on to the second part, just temporal coverage. I'll just use an example of annual CO2 measurement from an office space in Europe. There were several CO2 monitors. I'm just using one as an example here, not an extreme one. It's a fairly regular measurement. In fact, during lockdown, so you expect CO2 to be fairly low. And I'll compare high resolution to low resolution and spot checks. So temporal coverage, this is 1 year workspace. It is a measurement in a workspace. You can see there are some gaps. We're measuring CO2 here. You can see there's not really too many problems because even the peak doesn't really go much beyond 900 or doesn't go beyond 900 at all ppm. For reference, usually above 1,000 ppm is where you start getting productivity issues. You might have, you're definitely getting lack of ventilation, right? And potentially overcrowding. So if I was to measure this on one day, right, 21st or 22nd of March, and I took the 95th percentile of that day, which is a pretty common way to measure things, that's where I would end up, just under 500 ppm. This is clearly not representative of the annual profile or close to annual profile of measurement in that room, right? So I took another arbitrary sort of day of the year, and I took the 95th percentile of that day, and it was slightly higher, but again, it was not representative. And it doesn't really matter which day I took because it wouldn't be representative, right? So my point here is spot checks, they can be helpful of an entire, remember you've done an entire day's worth of measurement here. So you sort of hung around there doing measurements for the whole day, and it's still not representative of the long-term evolution of CO2. So let me use just May as an example to show you what happens. But what if you had continuous measurement and you were, let's take the baseline to be 5 minutes. Every 5 minutes you were measuring something, which is what we were doing in this case. And what level of simplification would be acceptable? This is May, one reading every 5 minutes. And on the next slide, if I take one reading per hour as sort of the baseline, I say that this is what 100% coverage means. Temporal coverage is one reading per hour must exist. And if you see the, if you assume 5 minutes to be the truth, I know you can get higher resolution than that. It's entirely possible. We just happened to sort of land on 5 minutes in this case as the highest resolution we measured. What you see is an hourly average is fine. You can see most of the trends. You can see the peaks. The diurnal variation is quite evident. It makes sense if you look at this, right? I know that the variation is not huge because the area was quite sparsely occupied during this, during 2020, mostly just essential staff. But you can see that once per hour is still doing a good job. So let's compare this to like lower, what happens if we lower temporal coverage? And it'll make sense when I get to the end of this series about what I'm getting at, in comparing continuous versus spot checks in the context of temporal coverage. So what if you were measuring 1 per third every 3 hours? So this is in the next slide, I'm showing you 33% coverage, essentially 100% divided by 3. It's still okay. It's not really, it's still showing you the peak. In the next slide, we see it's 1 per 12 hours. We're already down to just over 8% coverage. I'm beginning to lose some information. I'm losing some of the diurnal variations and so on. And the peak is kind of vanishing. Then I do, in the next slide, I do 4% coverage, which is 1 per day. So 4% of the total hours in a year are being covered by a measurement. That's, just think about how small a number that is if you just do one measurement per day, which is already way more than you do in a spot check. And here you can see I've lost a lot of information. Next slide, you see that if I went once a month or if I take once a year, I would get less than 1% of coverage. And depending on whether I took the measurements on a high CO2 day or a low CO2 day, I could end up with radically different representative measurements, right? Again, the numbers aren't too big in this case, but you can see that there's clear differences and they don't represent the space. We have other examples of places that I couldn't show here that have 3,000 on a particular day. but that just happened on one day. Is that really a problem that occurs throughout the year? Well, you wouldn't know unless you did continuous measurement. So in the next slide, let's just sort of finishing up on temporal coverage. Most certifications require measurements every 1 hour or less. Many require active occupant feedback. So that's also an aspect of temporal coverage, because you don't just measure once a year what your occupants are thinking. You have to do it continuously. Highest resolution does not always mean better information, but lowest resolution will definitely lose information or sometimes be completely wrong. So, there is a very good argument from a temporal coverage perspective to be made for continuous measurement rather than one-off. So I'll just finish up with sort of the implementation ideas. I've gone through quite a lot of the technical aspects of measurement for human experience. It's really quite simple, the implementation workflow. You set some goals. Are they health? Are they comfort? Are they compliance? You examine the data. So you implement the measurement. You examine the data. You identify gaps. You include stakeholders. You refer to guidance. There's plenty of guidance from REVA, from Subt, from ASHRAE, from so many other standard setting bodies. And then you implement the actions. And of course, then you measure and verify. You might display the data for transparency. You might send it for certification. There are services that will send the data to certification automatically for you if that's an outcome you desire. And of course, you repeat. Again, not really rocket science said. This is pretty much a standard way of implementing any novel system in any situation. After installation, once the measurement and feedback system is installed, we got to keep in mind that there are some sort of you have to set incentives and responsibilities. So who is managing the data and the hardware? Is there somebody on site? Is somebody remotely? Who is the stakeholder who acts on the data? So somebody complains, you get feedback from a human, from an occupant, and who actually acts on it? Does somebody act on it? And who is affected by the collection of this data? You don't want to end up in a situation where people are unhappy with the data collected, and they don't want to show it, they don't want to act on it, and that could sometimes sort of make the problem slightly worse. Do you want to report for compliance and certification only? Do you want to also report for transparency and occupant confidence? So part of the improvement of human experience is also just displaying how the building is doing and showing improvement over time. And of course, do you want to integrate with building automation and control system, because all that capability exists now, and a human being doesn't have to be involved in every decision that happens in the building. So just finishing up, not every recommendation that I've talked about here applies to every single building. So obviously that's not going to be the case. It's quite simple to just think about developing a plan and then following to the highest reasonable level, and of course, reviewing and improving as you go. Just to conclude, in sort of looking ahead at where I think this area is going, sensors are certainly getting cheaper and better. This has been happening for a while, and I know there's a global shortage of semiconductor chips at the moment, but that's going to ease at some point. Compliance and certification is moving from design intent to operational measurement, definitely, whether it's the United States Green Building Council, whether it's neighbors, reset, really any certification. And you see the new recommendations from Subt, for example, and ASHRAE, they've started actively recommending measurement of human experience and air quality and acoustic quality and so on. And improving the communication with occupants can improve building performance, through comfort improvements, ventilation improvements, environmental outcomes. There's plenty of literature on this. I won't really go into the literature about why this is the case. Just, this has been observed. Finishing up with the key takeaways, and I hope I convinced you that these through my presentation, that this actually is I backed this up with the evidence and arguments. So, just to repeat, the continuous monitoring and feedback are a natural progression of green building practice. It doesn't have to be, cumbersome, complicated, expensive. It is the data gathered are useful, and you're essentially taking what is now best practice, and we're evolving it to the next level in building performance. And that's it for me. Thank you very much. I'd like to acknowledge in the next slide my collaborators at my company, and at the USGBC ARC. And for any further information on the last slide, please contact me at this address. And thank you very much for listening.
So thank you very much, Parag, for your presentation. Voy a seguir hablando en castellano, puesto que tenemos con nosotros a Inés, que va a hacer el ejercicio de traducción. Inés, por favor, soy de hablar muy rápido, entonces si ves que en algo necesitas que pare, dímelo, ¿vale? Porque vale. Siempre me pasa, entonces no tengas ningún problema. Quería primero, Parag, agradecerte la ponencia, lo fácil que lo has hecho y sobre todo también el hecho de que a través de estas cuestiones de monitorización, de alguna manera, le deis concreción a aspectos que normalmente, pues cuando hablamos de salud, bienestar, etcétera, son excesivamente ambiguos o al final tenemos siempre un todo vale, ¿no? Nos sirve cualquier cosa.
So Parag, she wants to thank you for your presentation. It's been very interesting, and she thanks you for giving a voice to these aspects of building with our sight towards well-being and health that aren't always delivered.
Thank you.
Y sobre todo también creo que hay un tema importantísimo en lo que has planteado, que es al final esa cuestión que nos decías de para los técnicos, de no simplemente entregar las llaves y en este punto hemos terminado, ¿no? Sino de analizar el edificio a lo largo de su vida útil.
Yeah, and it's very important what you mentioned about not just giving the keys to the occupants or the owners and just leaving it there, but actually following on the performance of the building and the importance of giving importance to these aspects.
Creo, de hecho, que puede suponer un punto de inflexión para el sector, porque necesitamos ese cambio cultural. Al final nos quedamos ahora mismo contentos con lo que hemos hecho y no sabemos si ha funcionado, si no. Entonces, sobre todo también de la mano de la vertiente de la salud, ¿no? De los profesionales de la salud.
So it's a tipping point for the industry because that way it's not just about the architects who worry about it, but also other people concerned, such as the health professionals. And so it's a very important matter that actually changes things.
Y yo creo que con estas cuestiones en mente, que también creo que han despertado el interés de mis compañeros, por lo que he ido viendo, vamos a ir a las cuestiones que nos han dejado en el chat.
So we're going to go on to the questions that have been written on the chat because obviously this has led to a lot of thinking from everybody.
En primer lugar, hay una cuestión que has pasado muy por encima, que hablabas de políticas en ingeniería, que has dicho que no querías profundizar en ellas, pero se da la circunstancia de que han despertado el interés de la audiencia, entonces no sé si podrías comentarnos algo más al respecto.
So you mentioned in passing, you didn't want to get into the matter of engineering policies, and people are interested in knowing a bit more about this. So if you could develop a little bit.
Right. So I use the word engineering and administrative policy, these two words. And the distinction between them, of course, is a little arbitrary. Depends on the particular team that's managing a building. And, you know, so broadly speaking, engineering policy is all those technical aspects of managing the implementation of monitoring and, more importantly, the actions that follow after measurement. Right? So, do you wanna go ahead?
Sí, yeah, thank you. Por un lado estarían las políticas de ingeniería, que no es solamente la implementación de estas medidas como los sensores y demás para comprobar cómo está funcionando el edificio, sino también el seguimiento que se hace y la acción que se toma después. Esto estaría por un lado, ¿no? Estas políticas de ingeniería.
Yeah. So, for example, I was reading this paper recently, which was published by a government body of scientists in the UK called SAGE about CO2 monitoring, the application of CO2 monitoring. And they make the same point where it's important to have technical policy in place which acts on the measurement to avoid disappointment, right? Because because you measured, people expect something to happen. And if nothing happens, then that system is no longer valuable. Also to avoid sort of unintended outcomes where you end up measuring the wrong thing, you end up doing the wrong thing. So I think what I'm trying to sort of clarify here is that implementing measurement is a good idea. It's a great idea, but it must be followed up with changes to the building operation based on those measurements and some kind of a stakeholder participation in who manages the data. I sort of refer to that at the end of the presentation.
Sí, básicamente digamos, las organizaciones encargadas de comprobar que se hace un seguimiento una vez se instalan estos procesos de medición, siempre subrayan la importancia de tener una política técnica a la hora de actuar sobre estas mediciones, ¿no? Y lo importante que es hacer un seguimiento de todas las quejas, todas las sugerencias, todo el feedback que dan los usuarios para luego hacer algo y que no se sienta como que como que son mediciones que no tienen un objetivo.
Y en esta misma línea que comentabais ahora de los usuarios, nos preguntan por aquí también con qué argumentos podemos convencer a los propietarios de los edificios de que realmente merece la pena invertir en medir, ¿no? y en optimizar después, si fuera el caso.
So in this same line of acting on the measurements, someone is asking about how with which arguments we can convince the owners of buildings that it is actually worth investing and acting on measuring and then rehabilitating or reconfiguring the buildings. How much we value these improvements.
Yeah, that's a difficult question, and I don't have a perfect answer to that. I guess it's the motivation to implement monitoring changes from owner to owner. So far, I can tell you what's worked for me. Right. One thing that's quite significant is that certification bodies now, like USGBC or Reset, are demanding a measurement. So in order to demonstrate to your occupants that you run a good building, it's COVID safe, it's well ventilated, it's got high productivity, you get a certification, and in order to have that certification, you must have monitoring.
Esta es una cuestión difícil y que desde luego que no es fácil llegar a una solución. Pero es importante implementar estos cambios, ¿no? Que se dan cuando el edificio pasa de un dueño o un constructor a otro. A él lo que le ha funcionado es, pues bueno, que está claro que estas organizaciones de certificación, el objetivo que tienen es precisamente mejorar la calidad de los usuarios del edificio, con lo cual es importante seguir todas las indicaciones porque al final son organizaciones de certificación, pero que a través de las mediciones se aseguran y certifican que todo eso lleva a algún lugar, que no cae en saco roto, digamos.
The second line of argumentation that often works is based around the quality of an office environment, for example, or really any environment, doesn't have to be only offices. The advantage with offices, of course, is you can point to literature that says that if you don't have optimal conditions, you lose productivity. And the problem is, of course, there's no meter for productivity. There's not a clock saying, oh, productivity has gone up or down, right? There's no meter. But the potential impact of a loss of productivity is very, very high compared to energy spend, right? So something that I find is often helpful is to show sort of nominal calculations. If this was your salary bill, and if you lost this much productivity as is suggested in the literature because of bad operation, then you would lose this much. So it's a bit hypothetical, of course, but then, so is any projection of the future is always going to be hypothetical, right?
La segunda línea, ¿no? de argumentación de esta cuestión tan difícil es que, claro, la calidad del aire y del entorno, por ejemplo, de un espacio de oficina afecta a la productividad de las personas que utilizan ese espacio. Entonces, claro, es difícil medir la productividad, no hay un sensor o un medidor que vaya a medir la productividad, pero está claro que hay mucha literatura que dice que demuestra que efectivamente la productividad baja cuando el entorno no es bueno. Entonces, el impacto es muy alto comparado con la energía que se tiene que gastar para mejorar estas condiciones. Lo que el doctor ha encontrado útil en este campo es que los cálculos nominales, los cálculos, por ejemplo, basados en el salario de las personas, son útiles para visualizar, para, digamos, que sea más fácil entender cómo funciona este descenso en productividad. Son casos hipotéticos, pero si, por ejemplo, vemos que un descenso en productividad tiene un efecto sobre nuestro salario, es más fácil verlo y llega más el mensaje de por qué es importante hacer estos cambios en un entorno como el de las oficinas.
And sort of the third related line of argumentation we often find effective is sort of the technical and compliance pathway. So, you know, you've designed the building to deliver a certain environmental quality, whether it's ventilation, whether it's temperature control, whether it's humidity control. And the only real way of finding out whether your design is working as intended, whether the building is operating as intended, whether the building is operating optimally, is to measure the outcomes, right? So we've been doing some work, for example, where we were in a building in California. It was a small teaching space, and there were some complaints about the room, and we happened to have a pilot project with the university, and so we ended up putting a CO2 monitor in that space. And every day, the CO2 levels would go to about 3,000 ppm or higher. Just for example, 3,000 ppm is like everybody had a pint of beer in there, or maybe two, right? So that's how everybody would have felt in that space. It turns out the building management system was actually, supplying air that it thought it was supplying air because it thought the damper was open, but the damper was actually stuck. It wasn't open. So the building management system kept thinking it's supplying fresh air, but no fresh air was actually reaching the space. And nobody discovered this in a 15-year-old building until somebody put a sensor in there and said, okay, well, this is obviously not working out. So, just from a maintenance and operations perspective, it makes sense to put monitors.
Digamos que la tercera línea de argumentación tiene que ver con los aspectos técnicos y de cumplimiento, ¿no? De la importancia de medir los resultados en un edificio. Ha puesto el ejemplo de un espacio de aprendizaje en California, donde había descensos en productividad, había quejas, entonces decidieron poner un sensor de CO2, un detector de los niveles de CO2, y descubrieron que estaba por encima de las 3.000 ppm, que es lo que ha explicado antes, que es un exceso, ¿no? de la polución, que equivaldría como a una o dos cervezas, como a tomar una o dos cervezas. Y entonces se dieron cuenta de que en todos los años en los que había estado funcionando el edificio, el sistema de gestión del edificio no había detectado que había un atasco en el sistema de ventilación, que el sistema estaba diciendo que sí, que estaba entrando aire renovado, aire limpio, pero se dieron cuenta, hasta que no pusieron un sensor, no se dieron cuenta de que había algo mal y entonces tuvieron que cambiarlo, ¿no? Entonces, es la importancia de un gesto tan simple como poner un sensor para detectar un posible problema.
Sí, de esta cuestión nos hablaba también con AMA, un especialista en estas cuestiones, Paco Vargas, que siempre nos dice no nos centremos solamente en, pues, por ejemplo, en cuestiones de ventilación, en la instalación de los equipos, ¿no? Sino en el mantenimiento, porque después al mirarlos nos encontramos verdaderas atrocidades y las cosas nunca funcionan como esperamos.
So in another talk by Paco Vargas, he stressed this point as well, how it's important not just to focus on the installation of air conditioning, etc., but also on the maintenance and the surprises that can arise when we do that.
Tenemos por aquí, Parag, muchísimas más cuestiones que por tiempo creo que se nos van a quedar un poco en el tintero, pero sí me gustaría, si te parece bien, pasártelas por escrito, si nos las puedes responder, y algunas las pondremos también a disposición de todos los asistentes en la página web para no demorarnos mucho más, porque tenemos cuestiones pues de cómo se dificulta la sensorización, pues, por ejemplo, con los efectos no visuales de la luz, si tendría sentido incluirlo, el tema de la monitorización en el libro del edificio. La verdad es que creo que han salido temas muy interesantes y no me gustaría que se quedasen sin responder. Perdóname, Inés.
Nada. Tradujo esto, ¿sí? ¿Te parece? So basically what she's saying is that there are a lot of questions that have been asked, very interesting ones, because the talk has raised a lot of, it's been very thought-provoking. So she's suggesting writing them out and sending them to you, and if you can write a reply, and then we would make them available to all the people who have been listening to this talk. And because there are important questions, like, for example, how to take into account things like the effect of radiation, UV radiation in an environment, or including all of these things in the book. These questions that seem very important, and we don't really have time to get deeply into them today.
Okay, yeah, sounds good.
Perfecto, pues muchísimas gracias una vez más, Parag, por unirte a nosotros, y por supuesto a Inés, que sé que se lo hemos puesto yo personalmente complicado, pero bueno, creo que lo ha resuelto con muchísima solvencia. Gracias a los dos.
Thank you, Parag, for everything. It's been very interesting.
Thank you for having me. Yeah.
Gracias.